Hello, 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 everybody, and welcome back. We are at the very last question, question 25 on our grade 7 Gauss contest. A box contains a total of 400 tickets that come in 5 colors: blue, green, red, yellow, and orange. The ratio of blue to green to red tickets is 1 to 2 to 4. The ratio of green to yellow to orange tickets is 1 to 3 to 6. What is the smallest number of tickets that must be drawn to ensure that at least 50 tickets of one color have been selected? Interesting. Okay, so we're going to have to eventually put ourselves in the mindset of a worst case scenario. But with these ratios, I think we should be able to work out how many of each ticket there are. So let's do that first. Okay? And how do ratios work? Okay? Well, if we say blue and green, red and orange and yellow are the numbers of tickets, then when we say blue to green to red is 1 to 2 to 4, what we're really saying is there is some number m, so that B is 1 times m, G is 2 times m, and R is 4 times m. So that's what we're saying there. Okay? And when we say green to yellow to orange, I think was the order. Green to yellow to orange is 1 to 3 to 6. There is, let's say, some n, so that green is 1 times n, yellow is 3 times n, and orange is 6 times n. Now, how does this help? Well, you'll notice green is on both of these. So I know that 2m, whatever m is the green, but that's also 1n, or just n, if we're talking normally. So n is 2m. I can take that and I can plug it back in here and say green is 2m. Yellow is 3 times 2m. It's 3n. So yellow is 6m. And then O, orange, is 6 times 2m, so 12m. And now I have, in terms of m, all the different numbers of tickets. How does that help? Well, I know the total number of tickets. 400 is the blue tickets, plus the green tickets, plus the red tickets, plus the yellow tickets, plus the orange tickets. But that's m, plus 2m, plus 4m, plus 6m, plus 12m. 12 and 6 is 18, plus another 2 is 20, plus 5 and 1 is 25m. And now I can figure out what m is. Okay? 4 times, I'm just trying to not use my calculator here for a moment. 25 times 4 is 100, times another 4 would be 400. So 400 divided by 25 should just be 16. Okay? So we get 16m here. So the number of blue tickets is 16. The number of green tickets is 2 times that, so 32. The number of red tickets would be 4 times 16, so 64. Yellow would be 96. And orange would be twice that, so 192. And you might want to quickly double check, does this all add up? And it seems to. Yellow and orange certainly come up a lot there. Okay. So now I at least understand how many tickets, but I mean, that was just a stepping stone to the original question. What's the smallest number of tickets that must be drawn to ensure at least 50 tickets of one color have been selected? Okay. At least 50 tickets of one color. So, well, who cares about the blue or the green? You can't get 50 blue or green anyway. So at least you're going to need 48 draws. And maybe in the worst case scenario, you know, the cruel mistress of fate makes it so you get all the blues and all the greens. Well, you don't have anywhere close to 50 of another ticket. So we definitely need 48 tickets, and that in the worst case scenario would draw the blues and the greens. Then how many more do I need to get 50 of one color? Well, you might say, well, you need 50 more. Yeah, but what if I get 49 reds and 1 yellow? You don't have enough there. So it might be possible that we also draw 49 reds, 49 yellows, and 49 oranges. Right? That's possible. You just keep drawing them out. You draw all the blues. Oh, I don't have 50 of something. You draw your next few and you just keep getting greens and greens. You have to put yourself in the situation where you say, what is the worst thing that could happen? What would make me keep drawing? If you got all the blues, well, you're not going to get 50 blues, so that was a waste. If you draw 32 greens next, well, you're not going to get 50 greens, so drawing all those 32 greens was a waste. If I draw 49 reds, and then I draw things other than reds, well, I'm not getting 50 reds. I'm not getting 50 yellows if I then start drawing 49 yellows in a row, and then suddenly it switches to oranges. But if I do all that, then if I draw one more ticket, well, it has to either be, so I've drawn all the blues and greens, it has to be a red, a yellow, or an orange, and that would get me up to 50. So that, and then one ticket more. Okay. So that's 48, 2 49s, and then a 50, or 48 and 1 is a 49, so 4 times 49. It's 48 for the colors that couldn't even make 50. 49 of each of the other colors where there are at least 50, and then the one more. So these two combined to be 49. So 4 times 49, 4 is 2 squared, 49 is 7 squared, 2 times 4 is 14, 14 squared is 196. That's the number of tickets I need to get. 196, there it is. Okay, you'll notice it beats out these ones here. The only thing that could be more is B. We're taking the advantage of the multiple choice nature. Say D is our answer, and we can see if you got 246 tickets, you would have had 50 a long time ago. Okay. The worst case scenario is you draw all the blues and greens because that's not helpful. You draw all but one of the reds you need, all but one of the yellows you need, all but one of the oranges you need, and then finally your next ticket is guaranteed at that point to be what you need. Okay? So there we go, nice little answer of D, and that wraps up our grade 7 Gauss from 2013. So thank you guys, as always, so much for watching. If you want to stay up to date, feel free to subscribe to the channel. The next thing I plan on going through would be the grade 8 Gauss. So look for the 2013 grade 8 Gauss next, or if you're looking for more grade 7 level Gausses, feel free to browse around the channel. I have done many of them. And yeah, once again, thank you for watching, and I hope you have a wonderful day. Take care.